In this video we're going to take a look at the second lab in the Common React Pitfalls category on the Veracode Security Labs Community Edition, and this lab is called Sneaky Links. Learn about a feature of HTML that can leave your React app open to XSS, cross-site scripting. So I've already just done this lab. Let's, in this case, click on Review to open it up. So when this loads up, we can see we have our memereview.com. I'm going to open this up in a new tab and just move that out of the way so we can focus on the code editor and the terminal here. It tells us that React escapes props by default and is generally very strict about what types of things it will render in a component unless you dangerously set in a HTML. So this makes it very safe against cross-site scripting, but it doesn't protect everything. So this was what we saw in the last example as well. And one of those things is the URI content. So if users are allowed to add links to external websites, React will not escape certain types of cross-site scripting attacks like the JavaScript pseudo protocol. And we have this application here, this memereview.com. It's similar to Reddit in that it allows users to add links to external sites and then write reviews of the content. First, we'll add some demo memes to explore the functionality of the app, so we can run this script at the terminal. We can actually go and have a look in the code editor and see. So this is going to run curl. It's going to send this off as post requests. So let's run that. We'll do /add demo data. So we're now able to move on to the next section, but let's go over to the app as well, refresh this and see that it's added on some reviews. We've got some memes here to check out. 7 out of 10. Okay, so let's go move on to the next section. So the next section is on URI Protocols, and it tells us that we're able to add inline JavaScript to href values of the A tag. As an example, copy and paste this into the browser in a blank tab. Alright, so we'll do that. And we get this link, which we can click on, and we get a JavaScript alert. Next, to check if our web application can be tricked into running JavaScript with this method, submit a new review with the following as the content as the link. So let's close this down. We'll create a new review. We'll just call it whatever. Create the post and then try and click on the link. And it didn't appear to display anything. Nothing comes up. Okay, that's because the developer of this application has a safeguard in place. Go to the server API and have a look at the code. Okay, so we'll take a look at that. And it says they've used the string starts with to purge malicious links. And you can see here, alright, so if it begins with this JavaScript, then it's gonna log that it's prevented XSS, and it's just gonna revert us to the hash, to the home. Okay, so this might deter some attackers, but it's still vulnerable. Can you figure out how? So there are a couple of ways it could be. Here's a filter evasion cheat sheet. There's also a really good cheat sheet on Portswigger's Web Security Academy. And if we go here and take a look at some of the possibilities for bypassing this, you'll notice here that we have capital letters, which is a potential bypass. And if we look at this case here, it doesn't look like there's anything checking the case sensitivity. So if we go and let's create a new review, let's paste this in here and change this to JavaScript. If this was also checking for lowercase and uppercase, we might want to try and use camel case as well, just change some characters in it to see how that goes. And we'll submit this, try and click on the link, and this time we get our XSS pop-up. So we've injected that successfully. Let's go next. This section explains to us that the problem here was the developer tried to use blacklisting. So using a list of inputs, specifying a list of inputs that they won't accept. This isn't a very good strategy because it requires maintenance and will probably never be complete. So it's easy to miss edge cases that the developer might not have thought of, or maybe which weren't discovered at the time and things like that. If you use a whitelist, you basically say everything is denied by default. You block everything except a list of acceptable parameters. So in our case, we expect any links to begin with HTTP and HTTPS. So they're the only protocols that we would whitelist, and then if we wanted to add more like mail to, it's easy to add those to the whitelist in future rather than having a big list of blacklisted protocols and potentially not catching them all or finding some issues around case sensitivity and things like that. So they're telling us to go and edit this. We want to make the change to the server API, and we have it down here at line 26 where we currently are. So at the moment it's checking to see if it starts with JavaScript in lowercase, then it's going to say prevented XSS. What we should say is if it doesn't start with HTTP, and it doesn't start with HTTPS, let's take a copy of this. Then we post that we prevented the XSS, and you can see that it's allowing us to go next there. We've saved that. Can we go and test this out now as well? Run that. And if we now go to create a new review, oh, we don't have that saved. Let me just see if I can go grab that quickly. JavaScript alert. We must complete this step. We already completed that step. What was it? Inject the alert. Okay. So let's try and do this again. It might not let us get to the next stage now because... So it's not letting us create that new review. In fact, it looks like it's actually reset for some reason. Okay, so let's go back and undo this, save and run, just so that we can now create this post, hopefully. Yep, there we go, we can create the post. Let's go. We needed to put that in capital letters actually as well, but that's fine. Okay, so we need to just redo this step, which is kind of annoying, but so we'll redo it. We get the alert. We go to the next stage here. Let's put all our changes back in, save it and run it. And now we're going to try and do the new review. We'll paste that in capitals to make sure we've actually fixed the issue, and you'll see that it's not creating the new post. So we have resolved it, and we can go on to the next stage. So for some additional protection against this vulnerability, we can ensure that links open in new tabs, and then JavaScript triggered by the links would still run but not on the original page, so there would be no XSS injection, although you would still be sending users to potentially dangerous, untrusted scripts which would be executed. So the attacker can simply do the same thing by supplying a link to their own website, even if they can't achieve XSS. So this is a trade-off to consider. Also, it says here that opening scripts in a new tab is actually undefined behavior, and the exact results will vary for different browsers. So top browsers at the time of writing this lab will open the script in a blank tab and prevent cross-site scripting, but it is possible to get around this in some browsers using advanced methods, so it shouldn't be the only line of defense. And adding this target equals blank to links actually introduces another vulnerability, reverse tab napping, which we can have a look at here. It says it's a separate topic and it's going to be in another lab, so we're not going into it in too much detail, but essentially reverse tab napping is an attack where the page linked from the target page is able to rewrite that page. So you would open a new tab and the original tab that you were on would be replaced with something of the attacking site's choosing. So if this is used in like a phishing attack or something, that could be particularly devastating because the user already trusts the original tab that they were on, and it may have been, to a legitimate high-profile website. So there'll be another lab on that. We'll not go into too much detail. To prevent the tab napping, we can also then add this rel no opener, no referrer. So to complete this step of the lab, we need to add this to the A tag on the review and post.js. So we'll go to post.js first, and Where is the A tag? We have our A tag here, so at the moment it's ahref for the link. We also want to add in this target blank, which will cause it to open a new tab, but it's going to introduce that tab napping vulnerability, so then we'll also add this to prevent that as well. And I'm going to take a copy of both of these, go to the, let's save that, we'll go to the review.js as well and add the same. Oh, hopefully I added it outside of the curly braces on that last example as well. Let's save that, and then we want to go back. It seems to have gone, allowing us to go on to the next step, but we'll do npm run build, and then it wants us to test our changes by adding a new review to the app. Just wait for it to complete the build here. So we can go back to the app now, go to new review. Although the JavaScript is blocked anyway, it doesn't allow us to place JavaScript. Just wondering what it's looking for us to actually observe here. Okay, it doesn't allow us to. Doesn't actually allow me to post at all now. Okay. Alright, well, we completed the lab there anyway. We need to note that the malicious links that were already added will still be there. So that's just like any cross-site scripting issue. If you have a forum or a social media site or something like that, and it's not sanitizing the user input, and there's malicious scripts are injected, fixing the sanitization issue won't remove the malicious scripts which were already injected, so the database would need to be purged of all the malicious scripts. They also recommend here using the node's URL API and saying you might want to go with a front-end solution instead, or an addition, which would improve the overall user experience. And it also notes that the JavaScript protocol for URIs has been partially deprecated in React, providing a warning on usage by default. Note this means that no additional protection is provided by default. So even if there were protection against unsafe content added, it's still a good idea to provide link validation for the sake of user experience. So you could use this node's URL API to do that, and the documentation is available. And that's been the second lab. In the third lab, we'll take a look at dangerously set HTML links.